राधे राधे सभी को। आज हम प्रॉब्लम सॉल्व करने जा रहे हैं जीएफजी प्रॉब्लम ऑफ द डे डुप्लीकेट सब ट्री इन ए बाइनरी ट्री. So the problem statement given is given a binary tree, find out whether it contains a duplicate subtree of size 2 or more or not. The two same leaf nodes are not considered as subtree as size of a leaf node is 1. So let's try to understand on the notepad. Let's say this is a given binary tree. In this, we have to find that a subtree is duplicate or not. So simply, what we can do, if we don't have to consider like 4 and 4, this is 2 times subtree, but we don't have to consider it because we want the length of number of nodes should be greater than or equal to 2, at least 2. So we are not able to. So 5 is also not correct, and 5 in this. And from consider this subtree and this subtree, it has number of nodes greater than 2, means 3, and this is the same structure as this 2 4 6. 4 is the left node of 2, and 5 is the right node of both the subtrees. So now, how we think about this solution? So because 4 and 5 no, won't be our solution. So if we are able to find any one of the subtree which is duplicate, we will simply return true. That means simply if we are there is no subtree which is duplicate, we will simply return false. Okay, so let's understand it. The pre-order traversal of this subtree becomes 2, 4, and 5, and this as well traversal will be 2, 4, 5. Okay, so what we are able to understand it is the pre-order traversal of subtrees are same, then this will be this can be the solution. Okay, now what we can do for this, uh, what if there may be some cases if this is subtree and in place of this there can be 2 and then 4 and then 5. Its pre-order traversal will be 2 and 4 and 5, but this is not our subtree which is duplicate. So for that what we can do, if there is left node is null, so what we will do, we will insert null as this position. So that's for that there will be no uh, duplicates. So let's try to understand properly with another example. Taking another example, let's take same example again. Uh, so what we will do, we will make for each node we will consider store the pre-order traversal of this subtree. Like for 4 and 5 there will be 4, and for 5 there will be 5 only. In a map or anywhere we can store it. And for two subtree, this will be our output. Like two in a string we will store in a string by making string. By 2 this becomes string, and for this 2 this will be become. So what we will do, it will be key, and then we will increment the frequency of this. So for this subtree, what we can do is store 3, 2, and 3 and dollar. If there is left child or right child is null, so what we will do, in place of that we will store the dollar sign for that. Okay. So let's say for 3, 3 has no child left child, so we will put the dollar sign for it. and then again comes 2 and 4 and 5. Okay, what if we are at the light this position? So what we will do, because it is not the proper answer, so we will simply return this. Okay, so let's try to understand the code now. So we have initialized a map, a data structure for storing the each string for the uh, each pre-order traversal of each subtree. So we started ambidextrous clear and solve function. What is the solve function? In the solve function, if root is null, means there is nothing. Then we will simply return the dollar sign. Okay. If string is started a string variable with null string. If it is a leaf node, then we will simply return this node in as a string, because to string we will convert this into data into string data type. So I'm returning if it is not a leaf node or not a null, means this is the middle node of any subtree. So we will add this into our answer variable and call for the left and right recursively and restore the answer. Then what we are doing here in this incrementing the frequency incrementing the frequency of ANS string, and we are returning the answer. Okay. So if there is any string in the map key which has frequency greater than or equal to 2, so we will return true, because uh, if we are able to get this string two times two times, then that means it is duplicate. So consider another example: 1, 2, 3, and then 1, 2, and it has 3. So it contains any substring not. So it is directly we can say it is not content. So for that each 3 becomes 3 and $2 and 3 for 2 this substring, and for 1 there will be only 1, we return for 3 3. Then what is the for this substring, and this 3 1 and whatever is this, simply append this, and for 1 this will be appended with 2. Okay, so there is no if each substring has pre-order traversal frequency is 1. So there is no substring subtree which has duplicates. So we will simply return 0 at the last. If it has any frequency greater than or equal to simply return at least we will get 1. So let's run this. Yeah, it's giving the correct result. So run for the. So it runs successfully for all the test cases. So I hope you understand the problem and the solution as well. You get the solution on the GitHub, where I have a repository called GFG problem of the day. So thank you guys